Hopefully you've heard of the scientific method before, but scientific method is a process by which we do experiments. Now, not all scientific discoveries are made through the scientific method. Plenty happen by accident, or what some will call serendipity. Or we'll see something, and it'll be like, that's odd. There's a scientist who has a quote like, the most interesting words in science is not eureka, I figured it out, I discovered it, but that's odd. And we see something. Now, at that point, yeah, we can set up an experiment. And the scientific method is the best way we have for trying to make sure that we are eliminating all outside factors that could influence and bias our results, and instead focus on just trying to determine cause and effect. You will see different lists of the scientific method that break things down into more details or less details. But the basics of the scientific method are that you make an observation, or a lot of times this will be described as have a question. Now, a lot of times you have a question because of an observation you made. And that may be as simple as, why is my door squeaking? Or it may be as complicated as, why do these two chemicals react? Or something even more esoteric than that. From there, we propose a hypothesis. We make an educated guess. Educated is going to depend on how educated you are. For a little kid, gravity is mysterious. It's frequently described that Newton, which this is an area of physics, but that Newton discovered gravity. If he discovered gravity, then my kids are geniuses, because when they were babies, they'd sit there in their high chair and they'd push a bowl off the tray because they knew it would fall to the floor, and we would get upset and it entertained them, and then we'd put the bowl back on there and they'd try it again and they'd try it again. They discovered gravity. Really what Newton figured out is how gravity works. And for us, an educated guess is, if I take this pin here and let go of it, it's going to fall. For a little kid, that's not the case. My wife used to teach preschool. She did a little unit on gravity with 3-year-olds. She gave them buckets, had them put stuff in the buckets, and turned the buckets upside down. The kids were then trying to see if they could get it to not fall down, and see if they could beat gravity. And she said one kid put it in there and then put the bucket on his head, and the thing hit him in the head, of course, but it didn't fall to the ground. He thought he had beat gravity. For him, an educated guess is very different than your and my educated guess. But we make a guess. However, the main purpose of this isn't just to guess. You could start the experiment without making a guess. It's to help you design the experiment so that you limit other things that could affect it, what we call variables. You want to try to just test one variable, one cause, to get one effect. Occasionally there's multiple effects, but we'll see, does this cause each of those effects kind of individually? Having a hypothesis, this causes that, allows us to then eliminate all the other things that could cause that. My favorite experiment to describe in this regard is a pendulum. How fast does my pendulum here swing back and forth, go tick tock, and you could change the length of the string. You could change how heavy this thing is. You could change the angle that you pull it back at. You could change other factors about this. And it turns out, of all three of those, only one of them does actually have an effect. I'll leave it to you to play around with it and see if you can't figure it out. Or if you take physics with me, we'll get into that. It turns out that of those three, only one of them has an effect. Well, we don't want to change the mass and change the length and change the angle, and we see that it goes tick talk differently, and then we repeat that and we change all three again. We don't know which one's causing the change, and so we try to eliminate all the others, and maybe we're only going to test mass first. So we put a heavy thing on here and we watch how long it goes, and then we put a heavier thing and go it, or a lighter thing, and we see, does changing the mass here have an effect? And then we repeat for the other things. We keep the mass the same and we change the angle. We keep the mass and angle the same and we change the length, and see which of those has an effect. But here I'm getting into describing the experiment. The experiments are done to test a hypothesis, and it might take more than one experiment. The scientific method really is a iterative or repeative process. And from there, we try to draw conclusions. We are testing to see whether our hypothesis seems to be true or is false. Einstein is known for a quote where he said, "No amount of experimentation could ever prove one of my theories true." But a single experiment could prove it false. If we can prove it false, we've got to go back to the drawing board. Now, maybe it needs tweaked. It's not totally wrong. It's just not perfect yet. It's not the best explanation we can have yet. But seeing that the hypothesis is supported doesn't mean that the experiment is proving it true. It just means that we failed to falsify it. Science really is about trying to falsify our hypotheses, and we keep testing them. Now, the more we fail to falsify them, then the more confident we can be that they actually are correct and that we're good.
So this here is simply a diagram version of it, and that iterative process that I mentioned, you can see here where we do an experiment and we can repeat this process and go through this cycle multiple times. It does say here that we kind of get lulled. To be honest, I kind of think of that as a conclusion thing, and frequently in science we don't call them lulls anymore. We prefer theories. Law kind of implies that it's dogmatic and it can't change, and theories do change. Now, having said that, I had a roommate who used to, he was a huge poli-sci fan, and he'd always say, "I have a theory about that," when he was talking about this politician or that one. And what he really meant was, "I have a crazy idea that's just my opinion that's not supported by any facts." That is not what we mean in science with a theory. A scientific theory is usually a collection of ideas together that are supported by multiple experiments. Laws are sometimes used, and they're kind of an older thing, but laws usually tend to be a very narrow thing, and then a group of laws together along with some other conclusions that we've drawn make up a theory. We're not going to get into the details of the difference between each of them, and there's even disagreement within the scientific community on that. As I said, the steps here can be elaborated on. I've even seen them shortened some. A textbook that I had in college was the most detailed, and to be honest, I loved it. I thought it was a gorgeous version of the scientific method I'd ever seen, but it broke some of these down into subpoints and so on, and it was like 12 steps long. But the textbook itself used the squeaky door example that I gave there. You have this squeaky door, and you don't know why it's squeaky, and so you try these different steps, and that's what the following slides are going to get into, but I kind of want to run through that. So you observe, or you have the problem that your door is squeaky. You hypothesize that it's because it needs oiled, and so you try oiling it. That's your experiment, and then the door is still squeaky, and kind of the conclusion there, honestly, is that your door is still squeaky, so you go back and you need to re-experiment. You need to re-hypothesize what's going wrong. Well, maybe it's just that the screws need tightened, and so you get your screwdriver and you tighten all the screws, and the door is still squeaky, and then that doesn't work either, and so you decide you need to replace the hinge, and then you go to the hardware store, and the hardware store is closed, and there is a reason for having that in terms of having, experiments that just don't work out, and you have to try again, or you have to modify the experiment and try. And anyway, it was a really basic example to say that scientific method is great at problem solving, and you apply things like this all the time. I remember one time I was on a university campus that I was not familiar with. I walked through the door to go to the restroom, and there's two doors there, and I don't know which one to go through. Now, obviously, I could have guessed and checked, but I real quickly noticed that this one here in front of me, the handle looks more worn, the door is faded and worn there, and it kind of makes sense that it'd be straight ahead. And it turns out the one to the left was a custodian closet, and which I checked out later on because I was curious, but I just kind of, without thinking about it, my brain drew the conclusion, or had the hypothesis, the one in front of me is the right one. And it was, like I said, silly example, but science, part of its power, whether you continue with science or chemistry or not, is its ability to problem solve and to help you critically think. This then goes through a thing on everyday science thinking. I'll let you pause and read through the 4 slides here if you're interested, but I like my example better. It's a little bit more personalized, and so we'll do that one.
Anyway, here we have a learning check for us then, and even though we didn't really go through details of defining each of these, we're going to identify each of these as observation, hypothesis, experiment, or conclusion. I'm simply going to go with letters here rather than writing out the whole word. My handwriting is sloppy enough, and even worse here on the computer where I'm trying to do it digitally. During your visit to the gym, your trainer records that you ran for 25 minutes on a treadmill. Well, that's data, and data is observations. Now, those observations occur during an experiment, but the information there itself is just observations. Scientific study shows that exercising lowers blood pressure. Here we have the study having occurred already, so the experiment has already happened, so we're at the end of the process here. That would be a conclusion. And the doctor thinks is a key word there, that your weight loss is due to increased exercise. That thinking is a hypothesis that the doctor has. And real quick, just for clarity, I'm going to take these letters and jot them down up here. So observation was A, B was conclusion, and C was hypothesis. And we did not see an experiment in this one. Same thing here. Now that you've seen one again, I encourage you pause these and try them on your own. But a blender doesn't work when it's plugged in. That is a one observation. The blender motor is broken. That is a hypothesis that I have. The plug has malfunctioned. That would be another hypothesis that I have. The blender does not work when plugged into a different outlet. That would be me testing something, trying something. That's going to be an experiment. You can argue as well that within that experiment, you've made the observation of it not working. There's a bit of overlap, especially when we're applying it to such a simple thing. It's part of why I don't think of the scientific method as this set thing, but kind of a process, this guide to go through how you have that. The blender needs repair. The textbook labels this one as a theory, but to be honest, that could be a hypothesis as well. I hypothesize that it needs repair, but maybe it's something else. Whatever it is. Maybe it's a power outage and you're dumb and don't realize that the lights are off in your house. And so it's not that the plug is malfunctioning, it's just that you don't have electricity going to the thing. And so thinking that the blender needs repaired is wrong when it's really just you need the electricity restored in your house. So again, it's more of a process that guides your thinking and not some fixed rigid thing. By the way, when it comes to things like homework questions, I'm not in control of what the textbook asks you. They may, play loose with these and pretend that something is one thing like experiment and theory here instead of something else. You'll just have to muddle your way through that. When it comes to things like a test question that I write, I promise I'm going to make sure that it is very clear cut and obvious what it is, using words like back here, the scientific study. Well, the study implies that this is a conclusion and not an observation. The doctor thinks implies that this is a hypothesis. I'm going to use keywords like that, not necessarily those words, but keywords that help you guide you and help you distinguish each of these apart from one another. And that finishes up section 2.